Hello dear students, mathematics, a whole new way to see the world. Someone says it is a sense, just like smell and touch. I can say you can also test the mathematics. Only if you have to put some hard work, lot of practice, 100% concentration, and of course some logical reasoning too. All these spices makes mathematics very magical. Believe me, mathematics is a magic which can be enjoyed by everyone. Anyway, we'll go to today's topic. Our topic is a theorem. Actually, it is based on similarity, areas of the similar triangle. But before proving that theorem, we need only two things. One is the similar triangle and another is ratio of the areas of two triangles. Using these two concepts of similarity, we can easily prove the theorem. When a theorem comes, students just they bother about how to write the proof and everything, but it is very easy. Only you will have to concentrate on the given and what we have to prove. These two things gives the proof of complete theorem. So let us see the similar triangle. And under certain one-to-one correspondence between the vertices. I said under certain one-to-one correspondence of the vertices, means this is the very necessary and compulsory part of it. Because there are 6 pair of correspondence between the vertices and at a time only one is true. Okay, so under certain one-to-one correspondence between the vertices of two triangles, if their corresponding sides are in proportion, their corresponding angles are congruent, then only we can say the triangles are similar. Now, every time it is not possible to write all the 6 elements of that particular two triangles. So what we do, we are having test of similarity of two triangles. Using this test, these are the sufficient condition. This is a necessary condition, but these are sufficient condition. So in that sufficient condition, we are having 3 tests. First is AAA test. Here again, under certain one-to-one correspondence, in two triangles, if all the 3 angles are congruent to each other, then triangles are said to be similar by AAA test. But now, naturally, we don't use this actually. We using AA test only. Why? Because we know sum of the measures of all angles of a triangle is 180. So if two angles of two triangles are congruent, then third automatically will become congruent. So we need not go for this. We just use while solving the problem AA test. Okay. Now we'll go for the second test, SAS test. Here again under certain one-to-one correspondence, if 2 pairs of sides of two triangles are in proportion and their included angle is congruent, then we can say that triangles are similar. SAS test. Okay. Now third test is SSS test. Naturally, as the name suggests, SSS means side, side, side. So again, under certain one-to-one correspondence, all pair of all the 3 sides should be in proportion. And if it is there, then triangles are similar by SSS test. It becomes very easy to prove the triangles are similar if we'll use test of similarity of two triangles. Okay, so we are going to use one of the tests there in proving the theorem areas of similar triangle. Now the second thing, dear student, it is ratio of the areas of two triangles. It is very important. See, here only we are using the term only two triangles. There is no similarity, nothing else. It is simple, the property of the ratio of areas of two triangles. Here similarity दिमाग से निकाल देना. Now, what is this? Ratio of the areas of two triangles is equal to the ratio of the product of their corresponding base and height. So A1 upon A2 is equal to B1 into H1 upon B2 into H2. You know what is the formula to find the area of a triangle? Half into base into height. Naturally, we are taking the ratio, so half will get cancelled and we come with this property. Here again, there are 2 cases. One is triangles of equal bases. If triangles are having equal base or common base, then what happens? Ratio of their areas will be equal to the ratio of their corresponding heights. Secondly, if the triangles are having equal heights or common height, then ratio of their areas will be equal to the ratio of their corresponding bases. And this using these 2 things, we can easily prove the areas of similar triangle. And believe me student, the proof of this theorem will become very easy for you if you understand these 2 concepts. Okay, now let's proceed for the theorem, areas of two similar triangles. So this is the theorem on areas of similar triangle. It is from the chapter 1, similarity. Okay, see the statement of the theorem, ratio of the areas of similar triangle is equal to the ratio of the squares of their corresponding sides. Okay, ratio of the areas of two similar triangle. So here triangles are similar, it is given to you. What you have to prove, that the ratio of their areas is equal to the ratio of the squares of their corresponding sides. And to prove a theorem, the very compulsory thing is to draw the diagram. In your board exam also, you see some notes are given on the first page. Here it will be written there that for writing the proof of a theorem, diagram is compulsory. If you will draw diagram, only diagram, you will get half mark. But if you will write complete proof, because most of the students learn by heart it, they don't understand the theorem. So they write complete proof, they forget to write draw diagram. So they will get 0 there, a big 0. So don't forget to draw the diagram. Actually, you should start writing proof of a theorem with the diagram itself. Because without diagram, you cannot write given, you cannot write to prove, you cannot construct something there. Okay, so these are the triangle. Original triangles are ABC and triangle PQR. And these two triangles are similar triangle. So in the given, we will write triangle ABC is similar to triangle PQR. Okay, now what we have to prove? The second part, ratio of the areas of similar triangle is equal to the ratio of the squares of their corresponding sides. So it will be area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. Okay, this we need to prove. To prove this, only triangle ABC and PQR are not sufficient, so we will construct something there. In every theorem, there construction if any, ऐसा वहाँ condition होता है. In every theorem, you need not construct something. So here we will have to construct, we have to draw segment AD perpendicular to BC, segment PS perpendicular to QR, and condition should be B dash C dash C, point should be collinear, Q dash S dash R, point should be collinear. Okay, now this makes your complete diagram. After that, after writing given, to prove and construction, we should proceed for the proof. Now while writing proof, students just learn by heart it, जैसा मैंने अभी कहा, but it is not necessary. Actually, you will have to focus on the given and focus on what you have to prove. These two things makes complete proof. So you have to concentrate what is given and what you have to prove actually. Okay, so just see here, given is two triangles are similar and you need to prove the ratio of the areas of two triangles. I told you the property earlier, ratio of the area of two triangles. Ratio of the areas of two triangles is equal to the ratio of the product of their corresponding base and height. So we are using here the triangles are ABC and PQR. So a ratio of their areas is equal to product of their ratio of the product of their base and height, BC into AD. BC is the base for triangle ABC, AD is its height, so BC into AD. QR is the base for triangle PQR and PS is its height, so it is QR into PS. So this is, now after writing this, we will just take the ratio of bases and ratio of heights. Area of triangle ABC upon area of triangle PQR is equal to this BC upon QR, ratio of the bases, multiplied by ratio of their height, AD into PS, and give the number, statement number 1. As we are going to use this further again, so you just give the number 1. Now this is, we got the left hand side of the proof. We got it. Now we should concentrate on the right hand side. To get the right hand side, we will use given thing. Okay. After seeing this, we got the ratio of the areas of triangle. Now you concentrate on the given. What is given? Triangle ABC is similar to triangle PQR. And if the triangles are similar, I told you earlier that their corresponding sides are in proportion and their corresponding angles are congruent. Now here we need only one angle, so we'll take only one angle. Angle B should be congruent to this, angle B will be congruent to angle Q. Okay, these two angles are congruent. So it is angle B is congruent to angle Q. We'll give the statement number 2 to this, and the reason will be corresponding angles of similar triangle. Here the reason was given. For every geometrical statement you need to write reason. It is very important. Without reason you will not get marks in the examination. Remember this. Now second, angles are congruent, corresponding sides are in proportion. Which are the sides of these two triangles? AB, BC and AC. So they are corresponding to PQ, QR and PR. So ratio will be AB upon PQ is equal to BC upon QR is equal to AC upon PR. This is statement number 3. What will be the reason for that? Corresponding sides of similar triangle. Okay, now we have taken this. After that we need to concentrate on AB square upon PQ square and BC square upon QR square. But see, here it is not AB upon PQ. What is there? BC upon QR. So we need the square of BC and square of QR. For that, if we will anyhow show that AD upon PS is equal to BC upon QR, we will definitely get BC square upon QR square there. So now we will concentrate on them. So for that, AD and PS, you have to find AD and PS in the diagram. This is AD, which is perpendicular to BC, and this is PS, which is perpendicular to QR. So we'll use these two triangles, ADB and triangle PSQ. So taking these two triangles will prove them they are similar to each other. From the statement number 2, we can take angle B is congruent to angle Q as they are the angle of these two triangles also. After that, we need one more triangle if we want to prove by AA test. So there is right angle triangle. We have constructed AD perpendicular to BC. So ADB is a right angle and PS perpendicular to QR. So PSQ is a right angle, and therefore angle ADB is congruent to angle PSQ. What's the reason? Each is 90. Okay. Now if these two corresponding angles in these two triangles are congruent, then the triangles are similar by AA test. So triangle ADB is similar to triangle PSQ by AA test. Now these triangles are become similar. If the triangles are similar, their corresponding sides are in proportion. So we'll write the corresponding side. It is AD upon PS is equal to AB upon PQ. You can see AD upon PS is equal to AB upon PQ. These are the sides of triangle ADB and PSQ. We'll give it statement number 4, and the reason for that is corresponding sides of similar triangle. Okay, after completing this, we'll just compare the two statements, statement number 3 and statement number 4. You just see what is common there. You can see the common thing, AB upon PQ, AB upon PQ. It is common. AB upon PQ is equal to BC upon QR, and it is also equal to AD upon PS. So you remember the transitivity property of similarity of triangles. So here the ratio of sides is given. So here we can use transitivity. If AB upon PQ is equal to BC upon QR and BC upon again AB upon PQ is equal to AD upon PS, that means all the three ratios are equal to each other. So here AB upon PQ is equal to BC upon QR is equal to AD upon PS. This is statement number 5, and this statement we have derived from the statement number 3 and statement number 4. This is your statement number 3, number 4. Okay. Now you can see this BC upon QR is equal to AD upon PS. Okay. Our aim was the same. So we can easily substitute this AD BC upon QR in the place of AD upon PS. So instead of this AD upon PS, we have just substituted BC upon QR. Now it will become BC square upon QR square. So ultimately ratio of the areas of two triangles is equal to the ratio of the squares of their corresponding side. We got the proof. And if we want to take these three sides here, it is given AB upon PQ is equal to BC upon QR is equal to AC upon PR. So it will become area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. And this is our ultimate proof. So we have proved. See student, what we have done, we have just used similarity of two triangles and ratio of the areas of two triangles, and using these two things only we have proved it. So you need to concentrate only on given and what you have. Okay, dear student, Let's see the application of the theorem of areas of similar triangle. For that, we'll solve some problems. First one is in the activity form. Example number 1. If triangle ABC is similar to triangle PQR and AB is to PQ is equal to 2:3, then you will have to complete this activity. Now you know that triangles are similar, so it becomes quite easy for you to write down area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ. Which side will be corresponding to that? PQ square. Okay, this is 2 square upon 3 square. 2 square is 4 and 3 square is 9. This completes the activity. Here you have used the theorem of the areas of similar triangle. Without that, it was not possible to complete the given activity. Now, next thing, example number 2. Here it is given triangle ABC and triangle DEF are equilateral triangles, and ratio of their areas is given 1:2, and one of the side is given AB is equal to 2. You need to find side DE. See, कहीं पर भी mention नहीं है कि triangles are similar. So how you will apply this theorem, particular theorem in that? Actually, equilateral triangles are always similar. You need not mention that these two triangles are similar. Any two equilateral triangles are always similar. So two equilateral triangles are always similar, and you can apply the theorem on the areas of similar triangle. Area of triangle ABC upon area of triangle DEF is equal to AB square upon DE square. AB is given to us. A ratio of the areas of two triangle is 1/2. AB is 4, so square of that, and this is DE square. Now by cross multiplication we will come to the stage DE square is equal to 16 into 2, 4 square is 16. By taking square root of both sides, we will get DE is equal to square root of 16 is 4, and we don't have any square root for 2, so it will be under the sign square root. So DE will be 4 square root of 2, and you can write the reason there, taking square root of both sides. So here you just see, student gets confused there. It is not mentioned that triangles are similar. So you need to see what is written there. Equilateral triangles are always similar. Now the third, this is the important activity of your book. Chapter 1 exercise में दी हुई है, and this is example number 3. What you have to do there, it is given, this diagram is given, triangle DEF. Here PQ is drawn parallel to DE. So segment PQ is parallel to segment DE. Area of triangle PQF is given. It is 20 square unit. One condition is given, PF is equal to 2 times DP. Then you will have to find the area of quadrilateral DPQE. Means you have to find the area of this particular quadrilateral. Okay. So area of triangle PQF, while solving whatever is given that we have to write. So area of triangle PQF is 20 square units. PF is 2 times DP. Now let us solve. This is activity, so we'll have to complete some of half of the problem is already solved there. Let us assume DP is equal to X. If we are assuming that this DP is X, what will be PF? It is 2 times DP. That means it will be 2 times PF. Okay. Now this, if we'll see this diagram clearly, this is given DPF. They are collinear. यहाँ आप reason लिख सकते हो D dash P dash F. So what will DF will be DP plus, here it will come PF. Okay. Now what is DP? DP is X, and what is PF? It is 2X. So X plus 2X makes 3X. Okay. Now let's come to the triangle. In triangle FDE, this is FDE, the bigger one, and FPQ, the smaller one. Okay. In these two triangles, these two lines are parallel, so we can make the use of properties of parallel line here. For the triangle, for the angle FDE, this is FDE. If we consider transversal as DF, then we'll get these two angles as the corresponding angle. Here the transversal is DF. So FDE is congruent to FPQ. So what will come here? Angle PQ. Okay. Next, the angle is given FED. This is FED. This angle is given to you. Now to this angle, which angle will be corresponding? Actually EF is the transversal here and these two angles will be corresponding angles. What is the name of this angle? FQP. So we'll just write down FQP. Okay, reasons are given there, corresponding angle. For this also you will have to write corresponding angle. Now if two corresponding angles are congruent, then triangles will automatically become similar by AA test. So here again we are using the test of similarity, AA test. Now if the triangles are similar, then we can use the theorem of areas of similar triangle. Now we'll take the ratio of the areas of two triangle is equal to the ratio of the squares of their corresponding side. So which corresponding side actually we have to take? Here it will come DF square and 2x, that is PF square. Okay, these are the corresponding side. Here DF is 3x, so whole square of that. PF is 2x, so whole square of that, and it is nothing but x square will get cancelled and you will be only with 9/4. Here you will have to write by theorem, reason आपको लिखना पड़ेगा, by theorem on areas of similar triangles. Okay, if using this, now we know that we'll just cross multiply, nothing is done there. Area of triangle FDE, we have taken this FPQ to this side, 9/4 multiplied by FPQ. What is the area of triangle FPQ? It is given this FPQ, the same angle 20. So you will write here 20, and after simplifying that, what will get? This 4 ones are 5s are 9 5s are 45 square unit. What will be the area of triangle FDE? It is 45 square unit. So FDE is the bigger one. If we'll subtract this smaller triangle from the bigger one, we'll naturally get the area of quadrilateral. So here area of quadrilateral DPQE is equal to area of triangle FDE minus area of triangle FPQ. So what is the area of triangle FDE? Just now we have got this FDE is 45 square unit and area of triangle FPQ is given itself in the problem. It is 20 square unit. So 45 minus 20 is 25 square unit. Like that you will have to complete this activity, and believe me, this activity comes for more mark and it is very important. So student, all the best. If you have any query, you can just comment in my box and I will just solve your query. All the best for your future. Stay home, stay safe. God bless you.